Hello guys, finally winter caught up and it's now extremely cold. It's snowing outside and what best to do than build a snowman. I thought to myself that probably I could build Ryanteck's snowman, which is called Snow Pi, and frankly it's not so appropriate as truly it isn't snowing, it is 16 degrees outside, winter is not here, and what happened to the weather? Honestly, I sound like my grandma, but this is so weird. Anyway, let's concentrate on building the snowman from Ryanteck and see what can we do with that afterwards. And where best to find information about the Snow Pi if not on Ryanteck's website? Where to click is rather obvious. I think you need to click here, and it takes you to the page where you can purchase the Snow Pi for as little as £5.99. Really just short of £6 is really nothing. It comes as only as a building kit, and these are the components that I just told you earlier on. But most importantly, there is a Snow Pi wiki you can use to run a bit of demo code, understanding a bit more of GPIO 0 and the soldering guide, which I'll follow with the build. And this is really all you need. This is what you get when you order your Snow Pi from Ryanteck, and it's obviously all the components in a small bag. So let's open it up and see what's inside. So you get the snowman, of course, really nice thick PCB, and then you have the 26 header, which is good for the Raspberry Pi B Plus and 2, but also for the previous model. Then there is a resistor ladder, which I'll show you later on in more detail, and a bunch of LEDs, one of which is for the nose. A couple of things before we begin soldering. There is something that needs to be understood about this ladder here. And also the fact that not all the transparent LEDs are actually white in color. There are some which are blue. I've already sorted them out, and Ryan gives you an idea on his website on how to choose between one or the other. In fact, how to understand which one is white and which one is blue. I'll show you another way that you can do that with certainty. If you have a good enough multimeter, that should help you with the job, and you should select the diode testing mode, and with the two probes on the table like this, you should be able to place the LED and lit it lightly, so that you know which color the LED it is. Don't worry if you put it the other way around, nothing will actually happen. You're not going to damage the LED. So this is actually a nice way of testing LEDs and understanding which color they are. So this is another blue one. Yeah. And this is white. I hope you see it from the cam. Good. With regards to the resistor network here, there are actually two types of it, of this type of component. This one is the one with a common pin, and the common pin should be identifiable by actually looking at the package, and there should be a dot on one of the sides which identifies the common pin. And I'll show you with the graphic what does that mean in terms of circuit. But another way of identifying the pin with certainty is certainly to use again the multimeter, set it to resistance, and with one of the terminals placed on one of the extremes, try and see what it's going to measure. In this case it is 330 ohm. If we were to do it on the other side, it would show a very different much bigger value. So that tells us that this is the common pin, and we know also, because clearly there is a dot next to it, but just for certainty, if we go pin by pin, all of them will show as 330 ohms. So with that out of the way, let's start by placing the header onto the Snow Pi Man. It goes like this from the back, and if you have troubles sliding the header pins into the PCB, try by placing it to an angle and then push it gently one after the other. My header here is a bit bent, and it doesn't actually fit too well, but if you do this way with a bit of technique, you should be able to place the header finally in. Not quite. Come on. One more. There. Now that it's in place, it's quite important that we keep it flat onto the PCB. So in order to solder it properly, you can use one of these things to keep it in place whilst we solder a couple of pins on this side. Then we can remove it and solder the rest. So I'm going to go ahead and solder the header onto the PCB. With the header in position, we can now move on to put in the resistor network. We identified the pin 1, which goes right here at the bottom of the snowman belly. So we go like this, and then what can I use to keep it in place? Well, I think I'll use a bit of blue tack. So I'll just put a bit of blue tack on the side here, so it keeps nice, and it keeps the resistor network nice leveled onto the snowman, and I can solder it. There, so the resistor network is in place, and now we can move on to the LEDs. Remember that when you put components as long as the resistor network or the header, the best approach is to fix mechanically the component on the PCB and then solder two extremes so that the component will stay firm in place after you can do all the remaining pins. So let's move on to the LEDs. The LEDs have a slight cut on one side, which is also identifiable on the PCB. So when you look at the PCB, you can see the symbol of the LED with this flat surface on one side, and if you can look at the LED itself, it's got the same thing. So on the flat side, you're going to put the shorter leg of the LED like this, and then try and keep it firm flat on the PCB so that when they all shine eventually, they will all shine in the same direction. If you move them a bit about, the effect won't be as great as it is. And so you just bend the legs like this, and that should keep the LED right in position. I'm going to do them all now. And of course, the other way of keeping the LED in place is to use some blue tack, which I did for all of the others instead of bending the legs. It really works as nice as before. It keeps the LED firmly in place, and they're all very nice and flat on the PCB. Now we can just go on and cut the excess of the legs like so, without needing to go too flat on the surface of the PCB. I'm just going to do them all now and clean it up. And as a rule of thumb, when you're cutting components, try and leave as much as the ones that don't need cutting sticking out from the PCB. So in this case I left more or less as much as there is for the network, for the resistor network. Sticking out that much, it's probably 1 mil, and that should do just the job. So the snowman is ready. Let's go on and test it. To place this Snow Pi onto the Raspberry Pi, you have to make it so that it faces the HDMI connector onto the version 1. It just goes like this. Whereas onto the Raspberry Pi 2 and the B+, you have to place it in the same way, facing the HDMI connector, but also on the pins onto the left of the HDMI connector, like so. For this test, I've hooked up the Snow Pi onto a Pi Zero. It's really nice and cute. And I'm gonna go ahead now and look the code available from the wiki from Ryan, which we can reach from here, as I showed you earlier on. Here is the test program, and you just simply can copy paste that into Nano. I've already done that, and I've created a program which is called Snow Pi test. So I'm gonna go ahead now and run it, and hopefully we'll see some LEDs coming up. And there they are, one after the other. I think Ryan's design is really good in that also is using these big LEDs, which are really what this Snow Pi man needed. So good, everything is working fine, so let's wrap it up. Me and my children loved to build the Snow Pi, and we like to have it around now in hope that maybe one day we're going to be able to actually make a real snowman made of snow. In any case, for the moment, that's going to be enough. I think it's a really brilliant tool, especially for beginners. That's what most probably your first project will be about, linking up an LED, and this is a much neater and tidier way than having resistors and LEDs up on a breadboard. So it costs really very little. It's a lot of fun. If you haven't got one, you should get one. That's all folks for today, and catch you next time.